Hello everyone. I hope all of you are doing great and you have had a exciting learning journey till now. Yes, okay. Thanks so much, Nisha. And since today is the last session, so and we have uh, four algorithms today to cover, right? So just we'll just start, and then after the algorithms are done, I'll also spend last 15 minutes showing you some packages that I promised, right? And the packages that can really help you analyze data without writing codes at all, right? But that does not mean that when you're learning R, you don't need to do code at all, right? R Commander being one of them, and then I'll show you some more packages today, right? Okay, so on that note, let's quickly start the journey. And today we're going to do KNN, KNN classification, K nearest neighbor. KNN means K nearest neighbor, right? So as you all have seen lot of classification algorithms we have done, right? So KNN is last classification algorithm that we have to do and in our curriculum that is there. And after that today we are going to do clustering, right? So let's quickly wrap up with KNN. Why did I leave KNN with clustering? Because KNN and K means clustering. They both are very similar dependent on the Euclidean distance formula, right? So that's why I do KNN and K means because they are very similar, right? So let's start with KNN. Okay, KNN. K nearest neighbor. KNN means K nearest neighbor. Or Ram, I said we will. I said that we'll probably not. Yeah, I said for project assistance, I have shared my coordinates in the Google Drive. You can write to me whatever doubt when you start working on the project and you have any doubt. You can just write to me because during the session we will not have time to discuss the projects. Okay, I mentioned that. I remember that. I said that you can definitely reach out to me for the projects. Okay, but not within the session. Okay, so let's start. K nearest, is that okay, Ram? Don't, if you face any issue, you can just write down to me. Okay, so K nearest neighbor. KNN means K nearest neighbor is an algorithm that classifies data points by majority vote of its K neighbors. Means just take a look at this picture, right? We have classes, we have three classes of data, blue, red and green, right? And if a new data point comes in, let's this the question mark is a new data point, right? And we have to predict in which class this data points to which class this data point belongs, right? We are going to look for within a k distance. The k is going to be defined by us, right, at the start. Within a k distance, sorry, uh, within a distance, I am going to look at, let's say, 5, or sorry, it does not involve distance here. Within, I am going to look at, I am going to define k, that I am going to look at, let's say k is equal to 5. So I will look at 5 nearest neighbors of this question mark, right? And has the maximum, whichever has the maximum number of votes, right? Or the points, the data points which belong to the category, the maximum data points which belong to the category. My new data point is also going to belong to that category. So what I mean to say is, right? So that's why it's called K nearest neighbors. Now this nearest neighbor, who are the 5 nearest points to my new point, right? That is defined by Euclidean distance. Anyone remembers Euclidean distance formula from your high school? Anyone who remembers Euclidean distance formula? Yes, what is it? X1 minus X2, right? Whole square plus Y1 minus Y2 whole square and whole to the entire power of 1 by 2, or entire thing I do a square root of it. Remember that? Now these x1, x2 and y1, y2 are the 2 points in the space x1, y1 and x2, y2 are the data points in the space, right? In a 2D space. Is that okay? In xy coordinates. So if this is my xy coordinate and this is my x1 y1 and this is my x2 y2, this is my x1 y1, this is my x2 y2, then the distance between them is equal to x1 minus x2 minus y1 minus y2. Clear? Euclidean distance formula. So based on Euclidean distance, you try to first pick 5 nearest point, because I have defined k is equal to 5. Now there is no formula for defining k as such, right? You can pick up k, but yeah, the value of k should not be too large or too small. We'll see that how do you arrive at a most optimal value of the k, right? As such, there is no formula. You just have to do hit and trial and arrive at the most optimal k. Is that clear to all of you? Right, so k nearest neighbor is an algorithm that classifies data points based on the majority voting of the k neighbors. So if this is my, I have taken k is 5 and these are my 5 nearest neighbors. So which category do you think the question mark should belong to? The new data point should belong to blue one. Everyone agrees? Because blue are maximum. Blue one are the maximum nearest point to the new data point, right? It is used to assign a data point to clusters based on similar measurement. A new input point is classified in the category such that it has the most number of neighbors from that category. For example, marking an email as a ham or spam. So that was just okay. So that is the crux of k nearest neighbor. Okay. Steps. Calculate the distance of the unknown data point with other training data points, that is shown, that is choose the number of k and the distance matrix. So distance matrix we are going to take is Euclidean. Identify k nearest neighbors. How many k? Use use category of nearest neighbors to find the category of new data point based on majority voting. Okay. When choosing the value of k, keep in mind the following points. If the value is too small, neighborhood is sensitive to noise points. Noise points are the points which are not in the cluster, right? If this is my cluster, the noise points are far away, right? If the value is too large, neighborhood may include points from other classes. If the value of k is too large, it may include the points from the other groups. Okay. So based on this is the Euclidean distance formula which I have just explained. The the distance between two data points is x1 minus x2 whole square plus y1 minus y2 whole square and whole to the power of whole under root, right? Okay, so that's it on k nearest. Now let's quickly go to R. I think most of these packages you have already downloaded, so just activate these three packages. Activate the three packages and do data validation. Line till line number 30. Data we are going to take is Irish dataset. Zip. I've already shared this, Arush. I've already shared this. Okay. In fact, I have already also shared the clustering file also, the clustering session also. Yeah, in session 8. Okay, let me show it to you. Session 8. Okay. Wherever you have these classification algorithms, you have k nearest neighbor. Okay. Got it? Okay, great. Anyways, you don't need this file for KNN. You don't need any, because if you write, you are writing the code. We are not using any external data set. We are just using Irish data set. Okay. So quickly, I'm sure all of you know what we are doing till line number 30. First, we are activating the three packages E1071, CA tools, and class, and then we are loading the data, viewing it, and then doing cross validation. Let others also complete, Nisha. Thanks so much for the confirmation. Class package is used for k nearest neighbors. Okay. Once you're done till 30, just type 30 in the chat window. Yeah, Arush, you can definitely increase the split ratio to 80-20 also. It's because this is a training data. I mean, training means this data set is very, I mean, meant for learners only. So it has a similar ratio. You can say the features it is capturing throughout it remains the same, right? So I've taken it 0.7. You can definitely take it as 0.8 also. Okay, what you're saying is 70% is, but the train data, okay, let me just check. Is it training data is having 90? Why would it have 90? Maybe I think 6, yeah, 90 observations are coming. That's a good observation. Okay, let me just take it 75 and see structure of training cluster. Hmm, just hold on. 8. It's not taking up the exact split ratio. This is happening first time. I mean, earlier we never had this issue, right, Arush? I think, yeah. Mm, that's strange. Wait, let me just check sample dot split. Fractional of the points on y will be set as true. Okay, then random point 0 to 1. Okay, try doing a fraction. Let's see if that works. 7 by 10. Again, it's coming out to be 9. See? Okay, I got it. You know what's happening? See, it has 3 species levels, right? So it is taking it is classifying into train and test so that species ratio is maintained, right? Because the species, there are 3 categories of species, right? Yeah, so if I put 8, it's taking, right? Yeah. So because it is maintaining that ratio of species, right, in test and train. So that ratio is not being able to maintain when I put 7, right? Because it's a smaller data set, that ratio is not being maintained. So that is why it is not picking up 105. Is that okay? Right? Did you get it, Arush? Others also, did you get this point? Why 7, even when I take 7, it is going to the nearest uh, split where it can actually classify it with the similar ratio of the species. Okay, okay, that can be the only reason, right? Because it maintains split ratio, maintains the ratio. Okay, so let's continue. Feature scaling. Now we scale both test and train. After we have calculated this, I'm going to scale them. Do I do the rescaling and then I run a k nearest neighbor. First, I put k, the value of k as 1. Okay. I mention the cluster that I have to create. Okay. Test data and train data. I mentioned train data, test data. Angela, KNN takes in scaling data only. Scales. You have to scale it before you put the final data, or before you put the data in KNN. Okay. So when I run a KNN at k is equal to 1 and do a I create a confusion matrix. So I get a accuracy. What is all of you getting a similar accuracy? It could be slightly different if because I have not used sample we have not used set seed. So you might have a different accuracy, right? Okay. We have not used set seed, so you can have a different accuracy, all of you, right? Okay. Next, just increase the value of k. Let's increase the value of k to 3 and see where you get the optimal 3, 5, 7. You can just try and see where you are getting a optimal accuracy, right? So if I put 3 k equal to 3, rest all the commands remain same. We are just checking the optimal accuracy. So if I take k is equal to 3, my accuracy comes to be 0.88. Earlier it was 0.9. So I'll try 5. K is equal to 5. It increased to 92%. When I take 5, it increased to 92%. I'll try. Similarly, I tried 7. I think I got the maximum accuracy when I used 93%. It further increased KNN equal to 5, 15, 95%, right? So, and I think 19 will remain 95 only. Yeah, it goes up to 95 for me. Yeah. So 15 within between 15 and 19, I'm going to pick up 15 only because I would not want to increase the K unnecessarily, right? When I am getting the accuracy. So 95 is the, is that clear? Choosing the optimal K. Scaling, Arush, we had done scaling earlier. Remember, it divides, we subtract all the numbers from the mean and then divide by the standard deviation so that we arrive at a rescaled value. It normalizes the all the values. See, if you remember, I told you, okay, let me explain scaling. If I look at Arush, 1 to 4 means pick 1 to 4. Okay, this one, it is picking only, scaling is done for column 1 to 4. Okay, all rows, first 4 columns. Before the comma, it say nothing is mentioned. So it means all the rows for first 4 columns. Okay, if I just write this, see what you get. All the rows, first 4 columns. Okay, scaling is done for first 4 because fifth you have the categorical data, right? Okay, yeah. Let, if I explain, see, sepal length, this, the sepal length has values on a very different scale compared to petal length and petal width, right? So all of these have values at a different scale, right? But I have to, when I have to use it in a model, I rescale it because each value, because this value is larger than this, but in terms of weight, I have a similar weight for all these 4 observations, all these 4 data points for first observation, right? I am using all of these 4 together to predict a class, right? So as such, there is no difference in the weight. But if I use these values directly, 5.1 will have far more weight than zero point 0.2. Yes, right? But I don't want them. I don't want that they should have different weights. So I rescale it. I normalize these numbers so that all of them are, I can use all of them uh, in the model directly without worrying about the weight. Is that okay, Arush? So that's why I normalize them. I rescale them. Okay, Angela, is that okay to you? You also asked the same question, right, earlier? But I think you asked that why are we doing scaling, right? Okay, so that's K nearest. Now, what we are going to do is I have shared session 9 clustering. I've already shared this, so you already have these files. Okay. Okay, so first let me explain clustering with the help of an example. Okay. Let's say I have these 10 customers, right? Based on the data of spend, I want, these are the 10 customers, these are the spends they have done on a website, and these are the number of items they have bought. Okay, so you can take a closer look at it. These are my 10 customers, the spends are given, and number of items they bought are given. Now, see what happens is whenever you a company, whenever a business wants to uh, create strategies, right, or create business strategies, let's say for customers, right, it's not going to create a single strategy for all the customers. Does it create? For example, if you talk about credit cards, right, they are going to give you promotion if you spend this much, right? If you spend 1 lakh rupees, right, then you will have some promotions running. If you spend 3 lakh rupees, then you will have some promotions running, right? And less than 1 lakh, you have some different promotions running. Yes or no? Right? So if you see what is, how are these promotions calculated, right? These are actually different clusters of people those who are spending less than 1 lakh, people those who are spending between 1 lakh and 3 lakh, and more than 3 lakh, let's say, right? So, but how this cutoff of 1 lakh and 3 lakh is attained, right? That is done based on the features of the customers, various features of the customers, right? Which helps them cluster, which helps business create clusters, and clusters are nothing but groups of observations or groups of data that uh, displays a similar feature, right? When I say a similar feature, means they have similar in terms of spending habits. They have similar spending habits. People those who are spending less than 1 lakh on a in a year, right? They are conservative on spending, right? So business would want to give them promotion so that they are able to increase their spending habits. The intent is very different. But for people, those who are, let's say, spending more than 300,000 a year, right? Business knows that these are heavy spend. These are spenders. I mean, people those who are used to credit cards, so they don't have to make them. Uh, they don't have to push. Business does not have to push them to use. Rather, they have to just keep them at that level and maybe increase their spending levels, right? So they would come up with a very different promotion. Let's say they will come up in the promotion, they would come up with some uh, premium gifts. But a for a person who is not spending 1 lakh in an entire year, they might come up with schemes which will push them to spend more, right? Are you getting it? So the characteristics of the clusters are very different, right? And that is what we do in clustering. In clustering, we try to cluster our observations based on the characteristics of those observations that we have captured, and then we, based on those characteristics, we try to uh, put them in a single bucket so that business can create strategies for them. Okay, let's see an example here. Like I said, these are 10 customers. These are the spending, and these are the items they bought. Now, if I want to cluster them, right, I will. You can see 1, 2, 6, and 10. Right, they are low spenders. Right, they are not very heavy spenders. They are low spenders. Then I have the blue ones. They are okay. I mean, they are spending. They have spent on this website not very low and not very high. So medium, you can call them medium spenders, right? And then you have the heavy spenders, high spenders, 8 and 9, right? They are extensively doing shopping on this website, right? So based on the spending, I based on the spends they have made, I try to cluster them, and I have been able to cluster them in 3 clusters. Is that clear? low spenders, medium spenders, and heavy spenders. Is this clear? Now there are different algorithms for clustering, right? We are going to learn those algorithms. Okay, before I proceed to that, let's take a look at one more interesting example. Marks of students. So these are the marks of the students, of 9 students, mathematics and science, right? So based on the marks, you have to cluster them, right? You have to cluster them based on the marks. And if I plot them, notice if I plot them, this is how they will be plotted. And you'll very easily be able to find that these belong to a single cluster, these belong to a single cluster, and these three belong to a single a same cluster, right? And that too is reflected when I just intuitively look at the marks 37, 42, 33, 42, and 38, 36. Then you have 53, 52, 53, 54, 55, 57. Again, put them in a single cluster, and similarly the third cluster 7, 8, 9. I can put them in a single cluster. Is that clear? What we do in clustering? But yes, right now we have created a cluster intuitively and without no, I mean we have just observed the spends, but if you have a million rows, if you have a million observations, then it becomes really tedious, and then comes in the algorithm, clustering algorithm, which will help us identify the clusters when we have huge amount of data. Okay, so let's see what clustering is, though I have explained it, but we'll quickly read through so that in case we have not missed any point. Okay, most importantly, it's an unsupervised machine learning model. Why unsupervised? In this, do you find any of the variable as dependent variable or independent variable? No, right? It is just none of them is dependent or independent. It's just some data is given, and then based on the data, the algorithm starts to classify them, starts to cluster them. So as such, there is no labeled dependent and independent data. Okay, so it is an unsupervised learning model. Clustering is a task of dividing the population or data points into number of groups such that data points in the same group are more similar to the data points in the same group than those in the other groups, right? In the same group are more similar to other data points in the same group than those in the other group. In simple words, the aim is to segregate groups with similar traits and assign them into clusters. Okay. Example, suppose you are a head of retail store and you wish to understand the preferences of a customer to scale up your business. Is it possible for you to look at each customer and devise a unique business strategy for each of them? I already discussed the same example by chance, right? Definitely not. But we can do, what we can do is we can cluster them, let's say 10 groups, and then based on their purchasing habits, and then use separate strategy for customers in each of the 10 groups. Is it clear what clustering is? The concept is clear to all of you? Please type C in the chat window. If clustering is clear, concept, type C in the chat window. Okay, thanks for the response. Okay, now there are different types of clustering algorithms. Connectivity models, prototype based clustering, centroid models, and then you have density based models and distribution based models, right? We are going to do three of them. We are going to do centroid based, we are going to do connectivity hierarchical, yes, and we are going to do density based. Okay, three types of clustering models we are going to do. So you can read through this. This is just theory. Connectivity is hierarchical clustering, then centroid base is k-means clustering, and density base is db scan. So we are going to do anyways these three models. Okay, applications, recommendation engines, we have seen market segmentation, social network analysis, search result grouping, medical imaging. So there, the application is, I mean, there is no end to the application of clustering because everywhere business has to cluster, uh, use clustering to apply different strategies on different classes of, different classes rather, right? Okay, K means hierarchical clustering and DB scan. Okay, so what is K means? First of all, we are going to understand what is K means clustering with the help of this example. K means is an iterative clustering algorithm that aims to find the local maxima in each iteration. This algorithm works in 5 steps. So it tries to cluster the groups by finding the local maxima in each iteration. Let's understand the steps. Let's see. Let's understand K means with the help of this small example. Suppose these are my 5 data points, right? So first I have to define K. K is here. See, in KNN, K was the number of nearest neighbors which you have to define, and in K means clustering, K is the number of clusters you want to divide the data into. Okay, so I first I define K is equal to 2, right? I want to split this into 2 clusters. Okay, specify first step is specifying the desired number of clusters. Let's choose 2. Randomly assign each data point to clusters. So I randomly assign each data point to the cluster. Means, let's say I assign this one, these 3 red in one cluster, I randomly put, and these 2 in one cluster. Okay. Now what happens is in K mean. When you have assigned, when you have made a random, you have assigned them, you have randomly created 2 clusters, right? Compute the centroids, compute the cluster centroids. Means cluster centroid means the average data point, the average of all the data points in the cluster. So that is called the centroid. Centroid of the data point in the red cluster is shown using red cross, and those in the gray using gray cross. But how did I arrive at it? Centroid of a cluster is calculated at the point that is the average of all the data points in the cluster. So for these 3 points A, B, C, 20, A is 2024, B is 3031, and C is 3420, right? For these 3 points, centroid will be average of X and average of Y. Is that clear? Right? Centroid is clear to all of you? So for these 3 red points, when I calculated the centroid, it comes out to be this red cross. And for these gray, it comes out to be gray cross. Right? This is our third step. Fourth step. Now when I have 2 centroids, right, I reassign each point to the closest centroid, cluster centroid. So I'm going to, for this data point, which is the closest centroid, this, for this data point, this red cross, for this data point, which is the closest centroid, gray, right? It is gray. So and of course these two gray. So I reassign them based on the closest cluster, and then after reassigning them, I again form a cluster based on the closest allocation of the cluster. Is that clear? And recompute the cluster centroids. Now recomputing the centroids for both the clusters. Now I again recompute these centroids for these two and for these three. Okay. So this time my centroid comes this, and let's say this point. Now I repeat this process, and if again my answer remains the same, that there is no shuffling in the clustering, it means I'm going to stop and my clustering has been done. Repeat step 4 and 5 until no improvements are possible. Similarly, we'll repeat, yeah. When there will be no further switching of data points between the two clusters for two successive attempts, right? It will mark the termination of the algorithm. Is the process of k-means clear? If you have any doubt, please let me know, or else type K in the chat window. Type K for k-means. Type K in the chat window. If k-means process is clear. If you have any doubt, you can let me know otherwise. Okay, can I have some more response? Really appreciate that. Thank you so much. Okay, great. Right? Okay, so let's go to, okay, I have one more example in Excel. Now, I'll take that and then we'll move to k-means. So, let's say I have 5 stores, and they have these coordinates x and y, right? Two products, product sales of product x and product y, right? I have 5 stores, sales of product x and product y, right? And I have to classify them under two, where I have to classify them into two clusters. Okay, again I have arbitrarily chosen k equal to 2, right? It will depend on how many clusters you want to create when you are working in a real scenario. Okay, for these 5 data points, okay, initially we consider I pick up one data point randomly, I make it as centroid. I pick up any other data point, day 3, I make it as centroid 2. Notice I have chosen the centroid among the same points, right? This time I've just randomly chosen the centroid among the given points only. Okay, so Euclidean distance, based on the Euclidean distance formula, I calculate the distance of each data point from first centroid and second centroid. Okay, so my first centroid is 1320, right? So day 1, the distance becomes 0, right? Because both are the same data points. And then you have calculated the distance for all other data points. Similarly, the next data point I chose was day 3, centroid 2, sorry, right? So I calculate the distance between each data point and centroid 2. So these are the distances. Okay. Now, each data point, I pick up the smallest, the shortest distance, and based on the shortest distance, I classify them into clusters. So this, between these two, 0 is smallest. Between these two, 5.1 is smallest. Between these two, again 0. Fourth, 2.24. And fifth, 2.24. Right? So I've just highlighted them. Now my new clusters become 1, 2, and 4. Are you getting it? So 1, 2, and 4 become my clusters, and 3 and 5 become one cluster. Is this point clear? Right? Now after that I calculate new centroids, simply the average of x, 3x, I mean average of x of 1, 2, and 4, and average of x of 3 and 5. Sorry, this one. Average of 3 and 5, and similarly for y. So these becomes my new clusters, right? Now again I do that distance formula, I apply, and I calculate the nearest point cluster for each of the 5 data points. And again I pick the shortest distance, shortest cluster distance, okay, for each data point, and I club them with that cluster. Okay, and as I said, since there is no change in clusters, then I terminate, then my algorithm terminates. Okay, and if you look at, if I plot these are the 5 data points, and you can very well see the clusters that have been suggested. These are the 2 clusters that are suggested. Clear K means, right? So let's K means, okay, this is KNN. Let's go to R. You have to install 3 packages. I'll share the names of these 3 packages. Cluster with a capital C and R, cluster with small c, and G tools. G tools work at the back end, and it is required for the working of clusters packages. Okay, so once you install the package, activate the 3 packages. I'm going to cluster them, cluster the Irish data, and see how the clustering happened by calculating the classification. So in line number 20, what I'm doing, I'm just removing the column 5, because that is what I want to cluster based on the 4 sepal length, sepal width, petal length, and petal width. So I just remove that and I create a new data set, Irish one. I think these are the steps you know already. And if when you're done till 22, type 22 in the chat window. After that, I'll explain K means. When you're done till 22, just let me know. Okay, we'll wait for more people to confirm. Others done till 22? Okay, thanks for the confirmation. Okay, now K means clustering. I assume that I have to divide it into three clusters, and I set the seed at 240, and I apply the clustering. K means clustering on entire iris data, right? This time I'm not dividing it into test and train. I'm just applying it on the entire data set. Okay. Center equal to 3 means number of clusters. Then n start. What is n start? It's a random set of clusters that it takes. So basically it is the iteration. How many clusters do it create randomly, and then arrive for each cluster it creates 20 iterations or 20 initial configurations, right? And then it reduces them down to 3, right? So number of it attempts multiple initial configurations and reports on the best one. This is n start. So you mention n start, and then you run this k means clustering. And when you look at the output of k means, line number 29, when I look at the output, it has given me three clusters of three sizes. These are the sepal length, sepal width, and petal width average, right? For all the three clusters, these are the cluster centroid means or the centroids, right? And this is how the classification has been done. And if I create a confusion matrix, I create a table for the original species, Irish dollar species, and K means re. That is the name of my cluster, right? So I get this confusion matrix, right? And accuracy rate comes to be 89%. What is your accuracy coming up? Can you just type in the chat window once you're done till accuracy rate? 0.89. Okay. I think all of you will get similar if you have set the seed. If you have set a similar seed, you'll get a similar result, right? Because the data set, the it's going to pick up, and I think since we are using the entire data set, we'll get the same. We have not divided also into test and train. So the order in which it is going to work, set seed will standardize that order in this case. Okay, since we are not using set seed with splitting, the order in which it will start, that is going to be same. So all of us will get a similar result. Okay, K means is clear. Those who are still doing can okay. If you've done till 54, just mention 54 in the chat window, and after that, okay, let's plot it also. After 54, model evaluation and visualization. So if I plot, this is my sepal length and sepal width. Now if I plot them, line number 66 to 68, I color them, color for clusters, I specify the title, plotting character I have taken 20, and I have created a chart for it. Line number 71, cluster centers or centroids. I've already shown that to you earlier. So this is only if I want centers for sepal length and sepal width, which I'm using, right? And if I plot these centroids, I'm plotting these centroids in the visualization using line number 77 and 78. You'll see the centroids. PCH, I'm using 8 star. 8 is a PCH plotting character which gives me star. Done till once you're done till 78, type 78. We'll wait for others to confirm. Okay. Okay. So 78. Then I'm I'm just creating. I'm just visualizing this cluster. Clus plot. A means function take care of its iterations. Yes, yes, right. Iterations, of course, it takes care of the iterations, right? All you have to mention is the number of clusters and n start. How many clusters iterations you want, right? You start with, but ultimately it arrive at three final clusters based on different iterations it do. It arrives at three final clusters. So clust plot. It helps you create the clusters. So this is a plot created for the clusters. Span is used to represent each cluster. Basically, the ellipsis. You can see the ellipse, right? That ellipse is, I mean, it's the shape of the ellipse that comes with the span. Okay. Rest everything is, we've already discussed all these. Shade, I'll just mention shade equal to true so that it shades the cluster. I can share this. You can, I'll share this cluster plot. You can try and create this cluster plot, right? Okay, so that's K means clustering. Now, what is hierarchical clustering? Let's take a look at what is hierarchical clustering. Do you remember this chart? What is it called? I have mentioned it earlier when we were doing heat maps. Do you remember this? Dendrograms, right? So we are going to learn how do we use dendrogram to cluster. Okay. Okay. Hierarchical clustering, as the name suggests, is an algorithm that builds hierarchy of clusters. Right. So it's in hierarchical clustering, we are building. We start from the lowest point. Means when I say lowest point, I mean I allocate all the data points into a separate cluster, right? So it allocates all the data points and it assumes that all of them belong to a separate cluster. And then based on the distance, based on the closeness of each data point with the other data point, it starts clustering them. Okay. So that is why it's built on hierarchy of clusters. This algorithm starts with all the data points assigned to a cluster of their own, then two nearest clusters are merged into the same cluster. In the end, this algorithm terminates where there is only single cluster left. So you would have probably done this fun activity or exercise maybe in your high school or later in life, that you just start clubbing them and you arrive at a one big group, right? So if these are my data points, let's say these are my 25 data points, right? So how does a dendrogram get created? First, my dendrogram finds that point number 9 and 23 are closest, right? So it clubs them and find a and form a cluster. Okay. So this distance of the dendrogram, the height of the dendrogram, this part, right? This small part of the dendrogram, the height represents the distance between the 2 points. Okay. The height represents the distance between the 2 points. Clear? So these two are clustered. Now next, when we saw what is the, we tried to find the nearest point to this cluster and we found 17, right? So 17 was the nearest point to this cluster, and notice this is the distance between 17 and this cluster which was first formed. Okay. So this distance, and now I club 17 also into this cluster and it becomes bigger. Now my cluster is this. Okay. Then similarly 16 and 24 were the had the smallest distance, I mean has the least distance among themselves, so they got clubbed. And then later on they got clubbed with 22 and it formed an one cluster. Now similar activity happened with 3 and 15, and the closest point to 3 and 15 was 7, and this became another cluster, right? Small clusters. Then similarly it found this one, put it in one cluster, this one put it in one cluster, and then mm, it clubbed 4 with 10 and 20, right? And then, yeah, next it found these two, 1 and 13, and then later clubbed with 12. So can you see it is forming small clusters and then clubbing them based on the distance. Now this length of the dendrogram represents the, as I said, distance between the clusters. Okay, and it kept on doing this activity till it reached and it was able to create one single cluster for all these data points. Now, okay, that is how this dendrogram is created and how you read the dendrogram, right? Now, next point, the result of hierarchical clustering can be shown using dendrogram. At the bottom, we start with 25 data points, each assigned to separate cluster. Two closest clusters are then merged till we have just one cluster on the top. The height in the dendrogram, the height in the dendrogram at which two clusters are merged represents the distance between the two clusters in the data space. Okay, this is clear. Now, how do you, this activity is done. Now, how do you arrive at the final clusters, right? After you create this dendrogram, the decision of number of clusters can be best depicted, can best depict the different groups that can be chosen by observing the dendrogram, right? So the best number of clusters you can find is if you draw two parallel lines, right, between the heights. If I draw two parallel lines, right, and let's say I draw this line and then this line, right, wherever my distance between the parallel lines is can be maximized, right, for A and B it can be maximized. I can try drawing two parallel lines anywhere, but the distance will be maximized between A and B. Are you getting this point? Right? Wherever this distance is maximized vertically without intersecting any clusters. So this 1, 2, 3, and 4, the line these the dendrograms, vertical lines, these two lines intersect. That will give me my number of clusters. That can be optimal. Are you getting this? The best line, the best choice of the number of clusters is the number of vertical lines in the dendrogram cut by the horizontal line that can transverse the maximum distance vertically without intersecting the cluster. So the maximum lines, first I will find where I have the maximum lines and then how many vertical lines these two lines have cut. That will give me the number of clusters. So in this case, how many clusters do I have? 1, 2, 3, and 4. Is it clear? Hierarchical clustering. How the algorithm runs at the back end. Okay. Two important things you should know about hierarchical clustering. There are two types of hierarchical clustering: agglomerative, bottoms up. Right? Like I showed you, what I showed you was agglomerative clustering. And then you have divisive clustering which is top down. You can also follow the divisive clustering approach, but the results are going to be same because in divisive clustering you will just start splitting the you will put all the points in a single cluster and you then start splitting them into separate clusters based on the distance. Ultimately both of them will result in a similar dendrogram and of course the same number of clusters. It is also possible to follow top-down approach, starting with all data points assigned in the same cluster and recursively performing split till each data point is assigned to a separate cluster. Is divisive clustering also clear? What do you do in divisive clustering? Type, okay, fine. Type D. If divisive clustering is clear, type D. If you have any doubt, let me know. Okay. What about others? Any doubt? Okay. The decision of merging the decision of merging two clusters is taken on the basis of closeness of these clusters, right? I've already shown it and discussed it. The two clusters are going to be merged, which are the nearest, right? There are multiple metrics for deciding the closeness of the two clusters. Euclidean distance is what we know. Then there are some other methods. We can define the methods in the algorithm, but we are doing Euclidean distance, so we'll stick to Euclidean distance. Okay, so that's hierarchical clustering. Okay, one more example I'm going to take for hierarchical clustering. Okay, so I have 5 branches, bank branches, which are selling mutual funds and saving accounts, and these are the sales for mutual fund and saving accounts, right? For these 5 branches. Now, how do you create this dendrogram and then how do you arrive at the final clusters? First thing, I'm going to create a distance matrix. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I create a matrix. And can you tell me why I am having 0 in the diagonal? Anyone? This is a distance matrix which is calculating the distance between branch 1 with all the other branches, then branch 2 with all the other branches, and branch 3, 4 and 5. Exactly, because it is 0 because it is showing me the distance between branch 1 and branch 1. This is 0 because branch 2 and branch 2. Then why I have left this blank? Why have I left this blank? Because it is the mirror opposite, right? It's just the mirror opposite to that of the data points below the diagonal. Is that clear? So I have left this as blank. Okay. So I calculate the distance matrix. I create a distance matrix. Then I start my agglomerative clustering. Right. First, I find which of these branches have the shortest distance, and I found branch 1 and 4. Right. So here, if you see here, I just club them together. Now branch 1 and 4 I club together, and then with branch 1 and 4 I try to find the distance between branch 2, 3 and 5. See, branch 1 and 4 club together, and for 1 and 4 the distance between, I try to find the distance between branch 1 and 4 together with all the three. So the distance points here are 5.10. I first try to, just a second, I first get the distance between 1 and 2 and 4 and 2. This is the distance between 1 and 2, and this is the distance between 4 and 2. Similarly, I find the distance between 1 and 3 and 4 and 3. So these are the distance I get: 1 and 3 and 4 and 3. See, 1 and 3, 4 and 3. Okay. Similarly, I take the distance between 1 and 5 and 4 and 5. 1 and 5 and 4 and 5, which is 10. Now, of these distances, I pick the minimum distance. I pick the minimum distance from these, and then the distance which is the lowest from this, I club that with 1 and 4. Okay. So I club 1, 4 with 2. Okay. I club 1, 4 with 2. Okay. So 1 and 4, the new clusters are 1 and 4, and I keep on doing this activity. Now, these are the minimum distances I've taken. Sorry, I don't club it here. My bad. I I calculate the minimum distances. Now I again create a distance matrix. 1 and 4 club there. I bring the minimum distances with 1 and 4 with all the three, 2, 3 and 5, and rest, these are the distance already which were there, right? 2 and 3 was there, 2 and 5 was there, and 3 and 5 was there, right? And then I create again a distance metric and I repeat this exercise. Find the smallest one, 2 and 2 with 1 and 4. Just a second. 1 and 4 is this, and then I find the smallest, yeah, 2.83. 3 and 5. I club them together. So this is my first clubbing happening. This is my first group of cluster. This is my second group of cluster created. And then I club this second group with B2 because the distance between B3 and B5 is closest to B2. I club them into one cluster and ultimately form a finer cluster. Is this clear? Is this in Excel? Is it clear? If you have any doubt, let me know. Otherwise, these are just the steps that I have explained in the dendrogram only. I'm just finding the closest distance and calculating and just picking the smallest, picking the cluster with the smallest distance. Okay, so that's what we do in hierarchical clustering. Okay, you don't have to, of course, do this. This is done at the back end only. And then, okay, now what we'll do is we'll go to R and we'll start with hierarchical clustering. I have K means, yeah, hierarchical clustering here. Okay, Arush has a question. Okay, no, I think that's fine. Okay, so okay, I think we already have. It's already 7:30. So let's take a break, right? It's already 1.5 hours. So we'll take a break, and then when we come back, we'll create a hierarchical clustering model, right? Okay. So I'm opening up the poll. Please do participate in the poll. Let us know how did you do in terms of pace and delivery. And I request all of you to participate in the poll. And the poll is open now. And I'm putting up a timer for 20 minutes. Please do come back as per the timer. Okay. Thank you so much. And I'll see you on the other side of the break.
Hi guys, as I told in the morning, I have shared the social media platform link. Please do provide your valuable feedback by using the link. And while providing your feedback, please mention the same name and the course name and the trainer's name which I have provided in the chat box. And once you are done with the feedback, can you please give me a confirmation in the chat as done once you have done with the feedback? It will take hardly 2 to 3 minutes of yours just to go ahead and give your valuable feedback, guys. It's very important for us so that we can improve in the coming sessions. And it will also help to the other learners to join to the same course. Thank you.
Okay. Hello, everyone. Welcome back. Thank you so much for participating in the poll, and request all of you to please put my name as DEEPAAK. Deepak. You can put Deepak Kabir also, right? But yeah, thank you so much. Really appreciate all of your cooperation. Project coordinates. Dini, first of all, can you put your comment in the public chat window? Okay, yeah, coordinate. Okay, okay, fine, fine. I'll put it. Dini, I'll just put it. Okay, I thought I have it. Wait, I'll put it right away. Just a second. I'll just take 1 minute. I'm just saving. Can you see it? Can you check if you can see? Can you check in the Google Drive? Yes, it's there. Okay, fine. Thank you. Thanks for the confirmation. And as I mentioned, whenever you're doing that social media activity, please put my name as DEEPAAK. Thank you. Really appreciate that. Okay, so now we'll move to hierarchical clustering. Okay, you need time for social media activity or it's done? I can give 3 minutes. Quickly do it, right? Just take 3 minutes and do that social media activity because that's also important. Appreciate that, Arush. Thank you so much. Okay, quickly do it, those who are doing it, and if you can confirm, if you confirm, then I'll proceed. Yes, Dini, yes, right. Dini, you're putting the comment in the public chat, private chat window. So please put your whatever doubts, whatever comments you have, please put it in the public chat window. Yes, it's the same file, Dini, you're saying that you have seen. One more minute, please do it. Those who are doing, appreciate all of your feedback. Okay, so let's start. I want you to open RStudio, activate the dplyr package for empty cars. We know this data set, right? Empty cars, we are aware. It's a data set giving you features and details about different types of cars, 32 different cars, right? Distance matrix. Remember that same distance matrix that we calculated in Excel? It didn't work. So this is showing you the distance between different cars. Then set the seed, and hclust is the command for creating a cluster based on creating a by for using a hierarchical clustering. If I plot this I create a dendrogram. I plot this distance matrix. I get a dendrogram. Line number 130 gives me this dendrogram. Oops, not audible. I'll repeat. I'll repeat. What did I do? Sorry about that. My microphone was on off. Sorry. I'll repeat. Okay. So all of you have calculated distance matrix, right? Distance matrix, right? Then I use hclust command on this distance matrix and I mention the method as average to get me the dendrogram. This will give me the dendrogram. And if you see, if I plot this hclust hierarchical underscore cl, I get this dendrogram. Line number 130 will give me dendrogram. Now, visually, if I see, I can easily see that these can be the three clusters, right? This is one. Either I club them, these two, but or what I can do is this one and this one also are the three clusters, right? So I pass a line from here just to see how many clusters it can comfortably give me this distance, right? So I pass this AB line at a height of 110 and I put a red color so that it's visible. So it has classified line number 37 and 137 and 138. Well, Classify all the cars into three clusters. Mazda, see, Mazda is in cluster 1. Mazda, RX4, VAG, both of them. If I look at this output, I can easily see Datsun. Datsun is also, it should be here. See, cluster 1. Hornet in cluster 2. So if you see Hornet 4 drive is in cluster 2, right? Hornet, this is also in cluster 2. Merc 230. Merc 230, there you go, right? So these have been clustered. So this is just, I'm just putting a border to the three clusters. Is that okay? Done till 141, type 141 if you're done till 141. Okay, okay, great. So there's another clustering algorithm, a very interesting one of my favorites though, is density based clustering. Let's understand what is density based clustering. See, we all of us now know k-means, right? What does k-means do? K-means cluster, k-means put all the data points in a single cluster based on the distance, right? Based on the distance, it clubs them and put them in a same cluster, right? Yes. Based on calculating the distance, it calculates the average of those distance and calculate the centroid, and then which data points are near, it will club them under one cluster, right? So it is suitable for spherical shaped clusters or convex clusters, right? Thus, they work well for compact and well separated clusters. PA means is good for well separated clusters like this one, right? This one or some of the clusters we have seen previously. Such cluster may such clustering may cluster loosely related observations together. Now, even if there are some outliers, right, or some noise, in clustering we call outliers as noise, right? Even if there is noise, some data points which are, it is going to put those data points into some cluster, right? It will not leave, K means does not leave any data point, right? It clubs them, even it includes the noise as well, right? So first, you can say a drawback for k-means is that it includes the noise, right? Each observation becomes part of some cluster even if the observation is scattered away. As the cluster depends, also as the cluster depends on mean value of the cluster's elements, that is the centroid, they get affected by the outliers, right? So because we are calculating the mean gets impacted by the extreme values. We all know this, right? So these are the challenges. And another one more challenge is that in K, there is no a scientific method of defining K, right? It you define the K based on your intuition, based on your understanding of the business, right? So another challenge with K-means is that you need to specify the number of clusters in order to use this. You have to define it before uh, before uh, creating the algorithm, right? You have to define the K. Most of the times we won't know what is the reasonable K. But I mean, I would not say most of the time. Sometimes you don't know what is the reasonable K. If the data is too clustered, I mean, it's too dense, right? It is difficult and it is not easily separable, right? Many a times we don't know what is the optimal value of K. Now, what happens in DB scan, you don't have to specify the number of clusters. All you need is a function to calculate the distance between the values and some guidance on what amount of distance is considered close, right? So you need only two parameters here. First is the distance and second is the guidance on what is considered as a close distance. Okay, so if you see K-mean may classify these clusters this way, right? But if you see DB scan, if and these are like, as I said, not circular or you can say the spherical clusters. These are some clusters which have different shapes, like this one. So for those clusters, density for these clusters, density based scanning, then density based clustering is better. So density-based spatial clustering for applications with noise, that is the full form of DB scan. Now, how does density-based clustering happen? Clusters are dense regions in the data space separated by regions of the lower density points. So you can see what are clusters? Clusters basically, in clusters there is high density, and then it is separated by spaces which have low density, like is shown here, right? So DBScan algorithm is based on intuitive notion of clusters and noise. The key idea here is that each point of a cluster, that for each point of the cluster, the neighborhood of a given radius has to contain at least a minimum number of points. So that is the key guiding idea behind DBScan, that there has to be a minimum density or minimum number of data points in the neighborhood. If there are some minimum number of data point in the neighborhood, I will club them under one cluster. The key, yeah. Partitioning method, that is K-means, and hierarchical clustering work for finding spherical shaped clusters. In other words, they are suitable only for compact and well separated clusters. So uh, if you have a data which is not well defined, right? Not well defined. I mean, it's not very well clustered. You can't see the clusters very easily, right? You can't define the cluster characteristics visually. You can't see them, right? In such cases, DB scan works much better. They are also severely affected by the presence of noise and outliers in the data. In K-means and hierarchical clustering, because it is K-means is also distance based, hierarchical clustering is also distance based, right? They get impacted by the noise and outliers. In real life, data may contain irregularities, like clusters can be of arbitrary shapes as shown in the figure. So these are some arbitrary shapes. Clusters can be of these shapes, right? Also, they may contain noise, as you can see, outliers and noise. So I would not want to classify noise. I would not want to classify noise in one of the clusters, right? So if you have noise, if you know that your data is having noise or extreme values, you would prefer DB scan. Okay, what DB scan, as I mentioned, required two parameters. EPS, it defines the neighborhood around the data point, that is, if the distance between two data points is lower or equal to EPS, then they are considered as neighbors. First, we define the neighborhood, that within this distance, if I have, let's say within 1 unit, if I have 20 data points, I will consider it as a cluster, right? So it defines the neighborhood and then counts the number of elements in that neighborhood. Now number of elements is defined by minimum points, minimum number of neighbors within the EPS radius. So these are the two things that you have to just remember. EPS is the distance, you define the distance that within this I'm going to check within 1 unit, within 1 centimeter, or whatever is the unit that is there. Within 1 unit, I'll check if there are 15 points, then they will be considered as one neighbor. Okay. As a general rule, the minimum min points can be derived from the number of dimensions in the data set. So this is just a rule, some rule you can use. Number of dimensions that are there plus one will be the minimum number of minimum points that is generally used, but need not be every time. The minimum value of min points must be chosen at least three. So at least three minimum points we chose, and then once you start creating the groups, once you start clustering them in as neighbors, you will find there are some core points. There, core points is a point which has more than the minimum points within EPS. So if this is, you can see this is the core point because I have defined min points as 4 and this point has more than 4 within 1 unit EPS. Okay. Then you have border points, a point which has fewer than min points within EPS, but it is in the neighborhood of the core point. So border point, you can see these border points, they are on the border and each of them have just on the edge, minimum points on the edge, right? Or less. And then you have noise and outlier, which are far outside and they don't uh, have the minimum number of min points. They don't have the min points. Okay. Okay. So what are the steps that are there in DBScan? Find all the neighbor points within EPS and identify the core points or visited with more than min points neighbors. So basically we start picking up, we start clustering them based on the minimum points and the distance. We start classifying them and grouping them. For each core point, if it is not already assigned to a cluster, create a new cluster. So if there is a core point and it is still not assigned to a small cluster, we create it as a new cluster and then recursively we repeat these steps. We find recursively all the density connected points and assign them to the same cluster as the core point. A point A and B are said to be in the density connected if there exists a point C which has sufficient number of points in its neighbor and both the points A and B are within the EPS distance, right? So if basically the logic that I've explained here, it is the same logic I've written here, right? How these are just mentioned as steps, right? This is the chaining process. This is called a chaining process. So if B is a neighbor of C and C is a neighbor of D and D is a neighbor of E, which in turn is a neighbor of A, implies that B is a neighbor of A. So the starts, chain effect starts and cluster starts forming. Iterate when we iterate it through when we do different iterations to remaining unvisited points in the dataset, we are able to create clusters which have high density around. And also in this DBScan, you don't club all the data points in the cluster. You have noise also, right? The points that do not belong to a clusters are noise. So that's the process of DBScan. And what we'll do is we'll go to R and this is another example of HClust which you can classroom cluster. You can try this example, right? Okay, but for now we are going to start with install these packages dbscan 211 and 212. Call package ggplot2 also, because we will need this to plot. Activate these three packages and set the seed. Multi shapes is a package of 1100 observations across three variables: x, a numeric vector containing x coordinate; y, numeric vector using y coordinate; and shape, a numeric vector corresponding to the cluster number of each observations. So this multi shapes is clustered. If you view this package, if you view this data set, x and y. So based on these x and y coordinates for the points, we are going to cluster them into different shapes. Now, if I apply k-means to this, and I mention, let's say I mention I want 5 clusters. So this is how k-means is going to cluster them into 5 clusters. 249, line number 249. So you'll notice I am defining the k at the start. 5 clusters I want, right? I can mention 4, then it is going to color them as per 4 clusters, right? 249, if you're done, type 249. Once you're done till 249, I'll wait. Yeah, yeah, random. Angela, these are random. 1, 2, 3, 4, 5 is a random set seed. It is just that if you use the same number, you'll get a same result as mine. Otherwise, you'll get a similar result, but a different one. Okay, because your data set that will be because your data set use that will be used for model creating a model. will be different. Okay, randomly, but it will be different. See, understand set seed is like a identifier for a random data set, right? If I use this same set seed, if you all of us are using same set seed, R is going to pick that same random. So you can take set seed as a identifier for a random data set. You can pick any number of random data sets from a data, right? So let's say I've numbered them. So this is a number, I'm picking it up. Two 49. When it's once you're done, just mention in the chat window. Okay, we'll wait for others. Now those who have done till 245, just go further and apply DB scan 253 to 258. So DB scan has also come up with 5 clusters, line number 255 and 56, and 31 noise points, right? So there are 31 noise points that DB scan has come up with. And when I plot this, this is how it gets plotted. And you'll see very clearly, you can see the noise. additional color, one for noise, right? Color additional number of clusters plus one for noise. Arush, right? And if I change the parameters and I again plot it, I get, this time I get three clusters, right? One, two, and three. So that completes our DB scan. Okay, those who are doing it, you can quickly do it. And once you're done till 275, just mention 275 in the chat window. After this, what I'll do is I'll take you through some very interesting packages. And we'll also run through Lubridate. We are left with Lubridate. Remember, I told you if we get time, I'll do it. I think we have good amount of time. I'll spend 10 minutes on Lubridate and 10-15 minutes on the packages. You have to submit R files only, script files. Screenshots with the output. You can put the screenshots of the output in the Word doc and then submit the Word doc. That will be better. Or create a PDF of it, right? That will be better rather than just submitting the I mean that JPEG. I think it should allow. We can check. I think it should allow that. It does not. Okay, then I think this question can be better answered by the learning success manager, right? So we'll speak to her, right? Just give me some time. We'll speak to her, and all your queries can be uh, answered. Word files are allowed, and even PDFs are allowed. I know, but I'm not. Okay, R script. There was a way you can. Okay, did I also show you R Cloud, R Studio Cloud? Did I show you R Studio Cloud? No. Okay. A very now, as I said, our community is really, because it's a competitive and they are getting competition from all corners, right? And so many new packages are coming up, so many new. Uh, I'll show you R Studio Cloud. This was R Studio Cloud. Sorry. See, all of you can open R Studio Cloud, sign up. All of you do this, right? It's already used. Okay. See, R has come up with R Studio Cloud also, right? And look at the environment that you are going to get is exactly like R, right? But everything or whatever you do, all the projects, all the, it will be saved in your cloud. See, I'll click on workspace, project, new project. Yes, yes. Just like Tableau Public, you still have to download Tableau Public on your system, right? But this is completely in cloud. Just hold on. It's deploying and look at the interface. You will not feel as if you're in a cloud environment. See, and everything will be saved. All, whatever you do, whatever you create, right? And all the shortcuts work here, right? See, Control L cleared, Control 1 opened my console, right? So you don't worry about losing a file. If suppose there is an issue with your system, your file is always saved in RStudio cloud. This was in beta phase till last year, but recently I think they released it. So you can see exactly the environment is same. You have help packages, everything. You can download the packages just the way you are downloading in your RStudio, which you have downloaded on your system, right? Okay, so I think a very powerful product and a very powerful tool they have come up. Okay, so next I wanted you to show you importing and data analysis descriptive. Okay, so we'll psych package we have seen. Stargazer, Stargazer package. This requires coding. Uh, Summary tools also requires coding, but Stargazer is, it gives wonderful outputs, right? If I run Stargazer package, look at the output that I'll get. People, okay. Mass. Yes, email, Sachin. Yes, you can put it on email. Hmm, not found. I'll just see where this people is coming from. Oh, I have created this. Okay. I have created this people data frame. Yes. So this is a data frame that I have created, and if you want, I'll share this codes. You can also create this people data frame, and then go to Stargazer and see the output you get from Stargazer. This is how you get the output, right? Okay. Then package finder I've already discussed. There's that panel we've discussed. Summary tools. Another interesting package, summary tools. Please download this package, summary tools. If I run summary tools on people, the same data set that I've just created, look at the output you're getting. So summary tools and Stargazer are very interesting packages. You can. Okay, now coming to the package which I want you to install this descriptor and Shiny. Install these two packages, descriptor and Shiny. And activate them. Shiny is a huge package, very big package for creating dashboards. Okay, though Shiny, there is a lot of coding that is to be learned to create that package. We are not going to do that, but Shiny with descriptor. When I run Shiny with descriptor, I run it, I launch it using this command, ds I have shared it, descriptive statistics. It's shared earlier. It's in session 3, yeah. It's in third session, Sachin. Descriptive statistics 3.3. So when you run this line, after you activate these two packages and you launch Shiny, see what happens. Look at the interface you get. This window will be open. This window will open when you launch Shiny app. 395. When you're done 395 and you get this window, let me know. And similarly, in the meantime, when you're doing it, I'll just see there is another package called SQC, library. SQC will do later. 395. How many of you got this window? Type 395. Arush got it. Okay. You have to run line number 395 ds underscore launch Shiny app. after activating descriptor and Shiny. I'm waiting for confirmations. Did you get this? No one got it other than Arush? Did you get this window open? How many of you got this window open? Okay, that must be, yeah, you can do that. Shiny, because Shiny is a big package, it has lot of dependencies, right? So please do that, right? Shiny will take some time to install. Please do that. Sachin, did you install Shiny? Did you install Shiny and descriptor? Could not open Shiny. Why, Saurabh? Any message it is giving? Could not find the function. After app, you have to put a bracket. You, okay? Did you activate this these two, descriptor and Shiny? Saurabh, this is a descriptor. Okay. So this, if you see, ts underscore launch Shiny app. Yes, install. Yes, yes. Do it. Install it. Okay. Install all the dependent packages. Shiny is a big one, so it might ask you some more packages to be installed. Okay, now you can install it. I'll just show you the output. Okay. See, upload file. You can upload if you want to. Okay, we'll go by the sample data. Let's take a sample data. There are so many sample data. Let's take MC cars, right? So when I click on MC cars, it gives me the description of MC cars, but I select MC cars, use sample data, right? If I want to change the data type, I can change the data type. If I want to rename the variable, I can rename it. right? And I click on apply changes, select variables. Do you want to select variables? Yes. MPG, and let me just see our empty cars data. Wait. Some issue. Okay, there we have. So cylinder and MPG will create. I'll select cylinder with displacement. Okay, got it, Saurabh. Good. Select empty cars. Use sample. If I want to change, I can change. Apply changes. Select variables. If I select no, I go to analyze EDA. See frequency table. Okay, I think transform. Select variables. I select cylinder and displacement. So all these EDA that you do, right? Explorative data analysis, all can be done just by selecting the variables, and it will create a frequency table. It will create, it will give you the descriptive summary statistics, everything it will give. Some, are you getting it? I don't know. Again, it's not working for me. Some error. I'm okay. I think my R, some issue with R. Just a second. Now let's see if it works. Data, sample data, apply changes, select variables. Hmm. I don't know. It's maybe some issue at the back end. It's not working. Okay, I'll show you another package in the meantime. SQC, install dot packages, SQC. I'll share this command. This is again, install this package. I'll have to restart. I think R is, SQC will give you an interface wherein you just have to drag and drop and the visualizations will be created, right? So if I run SQC, Are you getting SQC? If you run SQC, are you getting a window pop-up? And it has an interface? No? These packages, these was, no one is getting? Installing, okay. But strange. All these packages, I've worked a lot, and let's check Shiny again. Upload a file. I can let's see if I can upload a file. Okay, let me upload. There is some error. It's not picking up data. Otherwise, both these apps are code free. You don't have to write the code at all. And I'm just selecting them, and I've put the data also, but it's not error. It's giving me some error. Window is not opening. Maybe some maintenance activities going on at the back end, something like that. Otherwise, SQC, if you see explore, visualize your data. You can do data visualization using this package. Completely just the way you drag and drop in Tableau, right? It's a package. You can just drag and drop variables and create visualizations. But strange, it's not running today. But I think you can try these, right? Maybe a day or two, there's some maintenance activity going on. But all these packages, SQC, then descriptor, R commander, right? Yeah, you will get, definitely you will get the videos. I mean, on help videos there are there on the YouTube also, right? Right. So, okay, I think now what I'll do is I'll quickly take you through Lubridate package. Lubridate. Anybody who tried Lubridate? No? Okay. I know a lot of things we have done. So date and time advance. Yeah. Okay. So date and time advance. We will see in Lubridate package. Remember in the base R you used as dot date, and only there was one format in which you can add date. This is the only format, right? But in Lubridate you can change the format. All you have to do is just define the format this way, and you can change the format, right? I mean, you can put it this way, even with slash, you can shuffle the days, month, and year, right? All these things you can do in Lubridate. Let me activate this package, library Lubridate. There you are. Library Lubridate. Now, if I want the time right now, I mentioned now, and I'll get the current time with the time zone. Today will give me the date. Now, if I take this, I assign this time to, and I check the class. This is all manipulating time and dates. Now, see, with Lubridate, I will use the commands, and I will using these commands like year, month, day, underscore, hours, month, and seconds. It's going to convert this time into, first, if I don't mention the time zone, it will convert it into UTC zone, Universal Standard Time, right? Then if you have notice here I have dash, here I have slash, even if I have date like these, sometimes from the systems you get date without any slashes, right? I can still convert them into proper dates, right? By mentioning DMY, or even I can mention MDY. If I mention MDY with the date, it will give me the dates. It's going to pick up and convert it into a proper date format. Okay, I can pick only date, I can pick only year, month, or day, whatever I want. Even week, it will give me the week of the year. W day will give me the working day of the week of that particular day, right? Hours, if it is time, it will give you hours also, and time zone. A little bit, I thought I'll just give you the introduction on Lubridate. So it makes it much easier when you have different formats of date coming. Lubridate makes it much easier to handle dates. Okay, so that's it from my side. Hopefully this journey has been useful. But yes, last parting note is consider this as it's not the journey, it's just the start of the journey. Okay, you will keep coming, you will keep coming. There will be lot of packages that will be coming up, and lot of better packages that will be coming up, right? So you will have to unlearn and learn, right? Unlearning is a very important part of data science. Okay, you will have to unlearn older things, you will have to keep learning newer things. And yes, since it's open source, everything is there. Google is God, right? You will find everything, all these packages, new packages that are coming. All you have to do is just follow some communities. And I think I did share the names of the communities, right? Stacks Overflow, right? And R bloggers is one. R bloggers, Stacks Overflow is one. Then there is one more. R pubs, yeah, R pubs. R pubs is one, right? So just keep learning, and I'm sure over the period of time when you practice and as you complete and submit your project, right? Do submit one project, but I would encourage all of you to try your hands on other projects as well, right? Okay, then thank you so much, everyone. Thank you. Really appreciate that. Thank you. Thank you. Really appreciate. And of course, hopefully it was lot of learning for you, and just get out of the comfortable zone, especially people those who are coding for the first time. It's not that difficult. You can also learn R and become very confident with it with a little bit of practice. Okay. And please put my name as DEEPAAK. Wherever you put my name, just put it as DEEPAAK. Thank you. Bharat, I have already mentioned it in the Google Drive. You'll find it. Okay. I cannot mention it here, otherwise it will, because this is recording and it's sometimes used later on, right? So, but I've mentioned it in the Google Drive. Okay.
Thanks for a wonderful session, sir. Hope you guys enjoyed the session. And I've already shared the feedback link for the today's session and also some social media platforms. Please go and visit that link and provide your valuable feedback for all the experience you had in this class. And if you guys face any difficulty while working on the projects, and also if you face any lab issues, you can raise the ticket. Just a minute, guys. I'll be back. Sorry guys, I have shared the feedback link and please do provide a valuable feedback. And also if you face any difficulty while working on the projects and you are not able to submit your projects and you need some extension for the project submission, you can reach out to the support team by raising the ticket so that they can help you out in resolving your issues. And while working on the projects, if you face any difficulty, you are not able to proceed with the project, just take a screenshot of it and with proper description, just raise the ticket on that. And if you guys have any other queries, you can please put it in the chat box. And please do provide your valuable feedback, guys. It's very important for us. And while giving a feedback name and the trainer's name, which I have provided in the link, and have corrected the trainer name as he told to please mention only Deepak. I have mentioned, please use the same and provide your valuable feedback. And once you're done with the feedback, can you please give me a confirmation in the chat by putting as done so that we'll come to know for all done their feedback. I've already sent the feedback links. First, again, I will send. Please use the feedback link which I'm sharing. And if you guys don't have any queries, we'll wind up the session for today. You will be getting all the details in your LMS. You can just go and check and you can register for that particular course. It will be automatically updated in your LMS. And thanks to all who are all given the feedback. And others, please provide your feedback. Only it will take hardly 2 to 3 minutes of yours. It will help us to improve in the future sessions, and also the learners who wanted to join the session, if the feedback given by you guys will help a lot for them. We'll wait few more minutes. If no queries, we'll wind up the session. For project submission, you will be having 15 days from today. Within the 15 days, you have to submit the project. If you fail in these 15 days to submit the project, just raise the ticket by requesting extension of the project. So that will be providing you the extension so that you can submit your project in that time. But only with some reasons, if you have some issues but were not able to submit in these 15 days, then only we will be providing the extension. But try to submit in the 15 days. You are welcome, Santosh. Okay, guys, thank you all. Boy, bye. All the best for your future. We'll wind up the session for today. Thank you. Next. You'll get, Azamuddin, you'll get all the details related to the live sessions in your LMS by just clicking on the available classes. You get all the details, what and all the batches are going on or upcoming batch details, everything you'll find out there. You can enroll to the batch which you are in comfortable with. And extension, you can just raise a ticket by requesting to provide an extension. They will provide. Sure. By going to the help option in your LMS, you can raise a ticket. And while raising the ticket, if you're facing some errors you're not able to resolve, just take a screenshot and with proper description raise the ticket so that our relevant team will connect with you according to that and they will help you out. Okay, guys, thank you all. Bye.